Welcome to Field of Study 1 Urban Water Engineering. My name is Jörg Treves and I'm serving as the coordinator of this field of study. So let's talk about what urban water engineering is all about. Primarily, it's about the provision of safe drinking water for cities and safe sanitation. And when we look at this historically, then usually we see that cities rely on imported water for drinking water supply. They use this water once mainly to flush away the waste out of the city and discharge to streams. And traditionally, energy has not been really a key driver in the design of these processes. But the discharge to receiving stream has resulted in major environmental impacts. Today, the water sector has many challenges. We see an aging and failing infrastructure in a lot of cities that needs to be replaced. We also see, with climate change, huge variability in the water resource availability and even economic or physical scarcity where there's not enough water to supply people and cities. Climate change has a major impact on water availability but also on water quality. And we see dramatic changes, not just in Europe, but worldwide. There's also increasing attention given to the energy requirements for water treatment. This little chart just indicates the specific electricity rate, and you see a tremendous jump in energy cost in Germany over the last 20 years. And there's demographic change. So by 2030, more than 80% of the world population will live in cities. And they have a major demand for safe drinking water, but also sanitation, but also energy, of course, which closely is related to water production. And there's a whole gamut of new contaminants we're concerned about, which might affect the water resource availability and safe supplies. Just to name a few. Of course, we're concerned about pathogens primarily. We're just talking about viruses every day these days. Antibiotic resistance is on the merge. But there's also concern about microplastics in the environment and a lot of chemicals we use on our daily routine, such as pharmaceuticals, household chemicals, personal care products, which might end up in the aquatic environment. With the water scarcity and climate change impacts, we also see a growing conflict over water demand for agriculture, irrigation. The urban irrigation even has some need, and we see some pressure even in Germany. Public water supply, of course, is a key area we need to provide a safe supply for. There's industry, which has a cooling demand for energy production, and we need to maintain ecological base flow in our rivers to protect the aquatic life. And you can certainly also think about for what we use drinking water. Maybe it's not even needed to use drinking water to flush toilets or irrigate our lawn. There's also increasing recognition given to perceive water as a resource. And you see this little pie chart here that in raw sewage, there's quite a bit of organic matter and nutrients contained. And of course, still H2O, water. So we can recover water, we can recycle water if we treat it up to proper standards that would allow a reuse and a reclamation. The nutrient content is quite significant, and if you manage to recover these nutrients, we can use them as fertilizers, for instance, and the organic matter is actually a major energy carrier. If you can design treatment processes that can recover this energy in form from biogas, for instance, you can recover more energy than it is actually needed to treat wastewater. So a major resource and an opportunity. Well, this all requires new concepts, and we're looking for integrated approaches to urban water infrastructure, and that's what you will learn in this field of study, using 21st century technologies and approaches, taking in consideration the energy requirements and the carbon footprint of these treatment schemes. Perceiving wastewater as a resource where we can recover energy, recover water, recover nutrients. And we want to integrate natural treatment processes because of their low carbon footprint and no residual generation. So that's a big advantage. Of course, we can take advantage of information technology in the 21st century, and we need to consider also economically and ecological aspects. So this brings us to a more integrated urban water energy management concept, where we use wastewater as a disposal issue, but as an opportunity to recover resources, to augment local supplies through non-potable and potable reuse, but also to harvest energy from these waste streams, as well as to recover nutrients. And this to protect our aquatic environment. So in order to address these challenges, you need to be prepared to address urban water engineering of the future. And we have set up 2 required courses of 6 ECTS each, and we'll start in the winter term with the Water and Wastewater Treatment Engineering course, which will give you an introduction to water supply and biological wastewater treatment engineering concepts. In the summer, we have an Advanced Water Treatment and Anaerobic Processes module of 6 ECTS, and this consists of 2 courses, Advanced Water Treatment Engineering and Reuse, where you do learn more about advanced treatment concepts and the opportunity to recover water and reuse it again. And the second course will deal with anaerobic processes and energy recovery, to see this as an opportunity to generate energy from waste streams. So to further broaden your expertise in this field of study, we put together a catalog of really interesting electives. You can gain further knowledge about industrial wastewater treatment and reuse opportunities. We will offer a course that is dealing with engineered natural treatment systems, wetlands, biofiltration concepts, which have a low carbon footprint to treat water in any settings, even in settings with very limited resources, for instance. We want to teach you some aspects of modeling of water quality in an aquatic system. So that's a modeling block course we offer. Hydrochemistry, water chemistry is very important to understand the design of treatment processes, but also to assess water quality problems. So you learn this in a lecture, and you have an opportunity to also take a laboratory at our chair to learn some hands-on techniques yourself. There's also another interesting laboratory we call the Unit Operations Lab, where you get to know unit operations, treatment processes, and you can, in a hands-on fashion, work with these units in the laboratory to gain some knowledge how they function. Desalination is offered by our thermodynamics department. Aquatic ecology and conservation is offered by aquatic systems biology in Weihenstephan. And we do have additional classes we offer in conjunction with experts from the field, practitioners, and they teach these classes in German. That deals with planning and operation of wastewater treatment plants, and also the design and operation of sewer systems and stormwater management. In addition, you can engage in study projects and math theses or other study work at our chair, the Chair of Urban Water Systems Engineering. And we have 7 research groups which are listed here. They deal with stormwater and drainage systems, and that's headed by Professor Brigitte Helmreich. We're dealing with advanced water treatment, which is headed by Professor Uwe Hübner. As I indicated earlier, we look at energy efficient wastewater treatment and opportunities to recover energy, and this is headed by Professor Konrad Koch. I also heading 2 research groups at the chair, the membrane filtration group and the water recycling group. Professor Würzbacher is heading the microbial systems group, where you look at microbial systems, pathogens, antibiotic resistance, but also using biomolecular tools and genetic tools to understand the function and the structure of biological systems, which are key to understand the function of natural systems, but also engineered biological systems. And we have a laboratory that is dealing with trace organic contaminants in the environment, which is headed by Dr. Knob. And here you learn the fate and transport and relevance of trace organic chemicals in the environment, in water, and treatment options which might exist to remove them. And last but not least, Professor Gondelica is heading the Water Energy Food Nexus Group, where you approach this from an integrated fashion from a planning perspective to bring together these elements in different settings. And lastly, when you choose this field of study 1, urban water engineering, you have several exciting occupational career paths you can pursue. You can focus on design of water, wastewater treatment plants, water recycling facilities. You can look at water quality monitoring and mitigation, or you can go more at the system level and design energy efficient urban water systems. These activities you can pursue at water and wastewater utilities or agencies, at engineering offices, consulting offices, at manufacturers of treatment processes, or at national and international water management administrations or environmental authorities. If you want to learn more about it, please check out our website, or if you have any questions, feel free to contact me. Thank you.